Hi, it's Sir Rob. Today I'm going to discuss data analytics in managerial decision-making, with the title Strategic Imperatives in the Data Economy, an executive overview of data analytics and its transformative impact on management decision-making. Traditional intuitive decision-making relies heavily on personal experience, gut feel, and subjective judgment, which can be valuable, but often leads to inconsistent or biased outcomes. In contrast, data-driven decision-making, empowered by data analytics, uses measurable evidence, patterns, and statistical insights to guide choices with greater accuracy, consistency, and predictability. By transforming raw data into meaningful information, data analytics reduces uncertainty, highlights trends that intuition alone may overlook, and enables leaders to make smarter, more objective decisions that align with organizational goals. As always, in the practice of accountancy, we should remember to be professional, perform effectively and efficiently, follow standards, and document our work adequately and properly. The topics of this lecture video include 1. The analytical foundation, defining the modern data landscape. We begin our discussion by establishing that today's organizations operate in a data-saturated environment where decisions must rely on evidence rather than assumption. We shall define data analytics and data-driven decision-making. We will also emphasize the 4 pillars of analytical insight: descriptive, diagnostic, predictive, and prescriptive analytics, and explain how these form a decision hierarchy that evolves from understanding what happened to determining the best possible actions. 2. The topic, Advanced Methodologies for Managerial Insight, highlights that managers today must understand both quantitative methods such as forecasting models, optimization techniques, simulations, and econometrics, and qualitative approaches like thematic analysis, interviews, and case studies. This topic stresses that mixed methods often deliver the strongest insights because they combine numerical evidence with contextual understanding. Analytics is not merely mathematical sophistication. It is about selecting the right method for the decision at hand. 3. The third topic, data-driven decision-making. The new management paradigm explains that DDM is grounded in 3 core principles: confidence decisions backed by reliable evidence, objectivity reduced bias through measurable indicators, and real-time responsiveness leveraging live data to act quickly. Emphasis in the strategic benefits of DDM, such as improved forecasting accuracy, transparency in decisions, and higher organizational agility, is also stressed. Also, the best practices like ensuring leadership buy-in, training staff in analytical literacy, democratizing access to data, and embedding KPIs into everyday workflows are discussed. 4. The fourth topic, strategic impact analysis, enhancing core management functions, describes how analytics elevate strategic planning by enabling firms to anticipate market shifts and simulate strategic scenarios. It discusses how data enhances resource allocation by pinpointing inefficiencies and optimizing budgeting, manpower, and operational workflows. The role of analytics in proactive risk management, enabling early detection of anomalies, emerging threats, and compliance gaps, is also highlighted. This section concludes by showing how customer analytics supports market personalization, delivering tailored products, targeted communication, and superior customer experiences. 5. The fifth and last topic, implementation challenges and data governance, acknowledges that integrating analytics is not without obstacles. This section discusses the organizational barriers such as resistance to change, lack of analytical skills, and siloed data. It addresses technological challenges involving system integration, legacy infrastructure, and data security. This topic also stresses the importance of data governance, with particular attention to data quality, ensuring integrity, that is, accuracy and trustworthiness, utility, relevance and timeliness, and objectivity, freedom from manipulation. Finally, it reinforces that governance is essential for building trust in analytics-based decisions. The discussion closes by reiterating that the analytical era requires managers to develop competencies in data literacy, critical thinking, systems understanding, and ethical stewardship of information. A concise roadmap for enterprise-wide data integration is also presented, which recommends building robust data infrastructure, cultivating analytical talent, standardizing governance, adopting iterative analytical projects, and embedding DDDM into all strategic and operational processes. Lastly, it emphasizes that organizations that master these capabilities will consistently outperform those relying on traditional intuition alone. And off to our first topic. The analytical foundation, defining the modern data landscape. Data analytics (DA) and data-driven decision-making (DDDM), a strategic definition. DDDM represents a fundamental shift in organizational governance, stressing the systematic use of analysis and empirical evidence to guide strategic choices, rather than relying solely on intuition or subjective, gut feelings. This approach ensures that managerial decisions are rigorously aligned with established business goals and objectives. The impetus for this strategic reliance on data stems from the sheer scale of information generated globally. Humanity currently produces over 402.74 million terabytes of data every day. If successfully collected, processed, and leveraged, this immense data abundance provides a solid, verifiable foundation for decision-making, significantly reducing uncertainty and increasing confidence in anticipated outcomes. Intuition carries a quantifiable, high-stakes risk premium. In an era generating over 402.74 million terabytes of data daily, relying on gut feel is a strategic liability. In the past, intuition-based decision-making is characterized by subjectivity, personal bias, and high uncertainty. Management that rely on unchecked gut feeling makes decisions that prove to have negative outcomes. The future will be dominated by DDM that relies on empirical foundation, objectivity, and confidence in analyzed data. Management choices from different prescribed options based on analysis will be aligned with business goals. The strategic value lies not merely in the volume of data accumulated, but in the disciplined process applied to it. Data analytics involves a systematic methodology that includes identifying the specific question, collecting the raw data, rigorously cleaning the data, analyzing the data using appropriate techniques, and finally, interpreting the results. The rapid accumulation of massive data volumes often creates a challenge where quantity risks amplifying noise and complexity. Without adherence to the systematic analytical process, especially the steps of data cleaning and interpretation, the specialized tools employed for processing this data, such as business intelligence tools, machine learning, or ML platforms, and extract, transform, load, or ETL tools may simply process unreliable inputs, leading managers to confidently make the wrong choices based on faulty foundations. Therefore, managerial confidence derived from DDDM is entirely contingent upon disciplined analytical methodology. The 4 pillars of analytical insight, taxonomy, and decision hierarchy. Data analytics is organized into a 4-stage progressive hierarchy that dictates the level of managerial insight and action derived from the data. Organizations typically transition from reactive analysis to proactive optimization by mastering each sequential pillar. The most fundamental level is descriptive analytics, which addresses the question, what happened? This involves the interpretation of historical data to identify foundational trends and recurring patterns, establishing baselines for performance. The next step is diagnostic analytics, which tells us why something happened. Diagnostic techniques are employed to identify the root cause of observed anomalies or problems. Moving into proactive territory, predictive analytics utilizes historical information to forecast what will likely happen in the future. Predictive models forecast future outcomes, allowing for anticipatory risk assessment and opportunity identification. Finally, prescriptive analytics sits atop the hierarchy, determining how to act. This involves employing testing and simulation techniques to determine which course of action will yield the optimal result in a given scenario, effectively automating or suggesting the best strategic response. Together, these four types allow an organization to move beyond simply documenting historical events and transition into genuine, proactive optimization. Our course will focus on the most advanced phase of data analytics, that is, prescriptive analytics, which is considered to be the holy grail of business analytics and is the most powerful tool in helping management and implementing data-driven decision-making. The analytical ecosystem, distinguishing data analytics, statistics, and machine learning. While often used interchangeably in general discourse, data analytics is functionally distinct from, yet interdependent with, several related technological and academic fields. Understanding these distinctions is crucial for managerial investment decisions. Data science is an interdisciplinary field that utilizes scientific methods, processes, algorithms, and systems to extract actionable knowledge and insights from both structured and unstructured data. Data analytics is the practical application of tools and methodologies derived from fields such as statistics and machine learning to achieve defined business outcomes. The relationship between statistics and machine learning, or ML, is particularly nuanced. Both disciplines are concerned with learning from data. However, statistics focuses primarily on inference, the conclusions that can be reliably drawn from a model, often requiring the formation and validation of a hypothesis before model building. Conversely, ML focuses on optimization and performance, utilizing algorithms to build and train models so that new information can be introduced based on previous occurrences, teaching the computer to learn and adapt without a predefined hypothesis. Data mining involves the extraction of information and the discovery of patterns from large, often unstructured datasets, relying on algorithms and statistical models. While data mining rules are typically obtained directly from the data available, ML specifically aims to create systems that adapt based on new data inputs and algorithmic learning. For the modern manager, data analytics relies on statistical rigor for foundational inference, utilizes data mining for robust pattern recognition within big data, which refers to large, complex data sets requiring specialized software to handle the 3 V's: volume, velocity, variety, and increasingly utilizes ML algorithms for generating complex predictions and automating prescriptive actions.
The second topic is advanced methodologies for managerial insight, which includes a discussion of the subtopics quantitative and modeling techniques and qualitative and mixed methods. Successful application of data analytics requires leveraging a diverse arsenal of advanced analysis techniques, which are categorized based on whether the input data is quantitative or qualitative. The objective of these methodologies is always the same: to transform collected, classified, and organized data into actionable insights for decision makers. Quantitative and modeling techniques. Quantitative data analysis techniques focus on modeling relationships and predicting outcomes using numerical variables. Regression analysis is perhaps the most commonly used quantitative technique. It allows businesses to model the relationship between dependent variables, the outcome being measured, such as the number of deliveries, and independent variables, the factors influencing the outcome, such as the weather. Regression is popular for use cases such as financial forecasting and data-driven marketing, enabling managers to understand how altering one variable may impact another. Time series analysis is crucial for strategic planning as it analyzes data collected sequentially over time to identify trends, seasonality, and cyclical patterns, enabling accurate forecasting of long-term demand or performance. Cohort analysis is a technique that involves grouping subjects based on shared characteristics or experiences, allowing managers to track their behavior over time. This is invaluable for measuring customer retention, understanding the longevity of marketing campaigns, and calculating customer lifetime value. For risk modeling and scenario planning, the Monte Carlo simulation is a vital computational technique. This method relies on repeated random sampling to model systems containing significant uncertainty, allowing managers to assess the probabilities of various outcomes. The utility of simulation extends far beyond simple risk reporting. By turning data analysis into a high-fidelity, low-cost strategic testbed, managers can virtually test new strategies related to large-scale investments or operational overhauls before committing real-world resources. This fundamentally changes the nature of strategic decision-making, moving it from a retrospective justification of past trends to a quantified assessment of future possibilities. Finally, artificial neural network, or ANN, analysis utilizes complex, brain-modeled algorithms central to machine learning and deep learning. ANNs are applied where complex, non-linear patterns are suspected and are essential for advanced predictive modeling. Qualitative and mixed methods. While quantitative methods dominate traditional analysis, modern data analytics increasingly incorporates methods that leverage qualitative and mixed data to provide deeper, contextual insights into human behavior and market dynamics. This integration signifies a critical progression in analytical maturity, bridging the traditional silo between hard numbers and customer narratives. Factor analysis is a regression-based method that can handle both quantitative and qualitative data. Its purpose is to reduce data dimensionality by identifying latent variables or factors that explain correlations among a larger set of observed variables. This allows for a streamlined interpretation of complex datasets. Sentiment analysis utilizes text mining techniques to analyze unstructured data sources, such as social media posts, customer reviews, and survey responses, to gauge customer emotions and attitudes. By combining performance metrics, quantitative, with the underlying motivations, qualitative, provided by sentiment analysis, managers achieve a holistic view, enabling them to address the why, diagnostic, of performance shifts with greater accuracy. Other qualitative techniques, such as discourse analysis and grounded theory analysis, offer deep contextual insights by understanding the structure of communications and developing theoretical frameworks directly from the collected data. The diagram on the slide presents an overview of essential analytical techniques used by data analysts to generate strategic insights based on qualitative and quantitative techniques. On the qualitative side, it highlights methods that explain the why behind customer behavior. Factor analysis is shown as a way to distill complex information into core underlying factors, making interpretation easier. Sentiment analysis is also featured, illustrating how analysts evaluate emotions and attitudes by examining customer text from reviews or social media. On the quantitative side, the diagram focuses on techniques that model the what. Regression analysis helps determine how changes in one variable influence another, while time series analysis tracks data over periods to uncover trends and support forecasting. Monte Carlo simulation represents a method for testing numerous scenarios to assess risk and probability before making decisions. Together, these tools combine qualitative understanding with quantitative modeling to support well-informed business strategies.
The third topic is data-driven decision-making, the new management paradigm, which includes a discussion of the subtopics, core principles of DDDM, confidence, objectivity, and real-time responsiveness, strategic benefits of data-led governance, and best practices for cultivating a data-driven culture. Core principles of DDDM. The move to DDDM is not simply an improvement in reporting. It is the establishment of a new management paradigm founded on confidence, objectivity, and continuous responsiveness. DDDM provides a strong counterpoint to reliance on subjective judgment. By providing an empirical foundation for choices, data reduces uncertainty and generates higher confidence among decision makers, leading to sustainable growth and profitability. A key principle of DDDM is its capacity to guard against bias. Traditional intuition-based decisions are susceptible to confirmation bias or hierarchical influence. Data analytics provides an objective lens, minimizing personal biases and enhancing decision integrity. For instance, a US-based energy company actively implemented the biasing techniques and raised awareness of cognitive biases among leadership to ensure objectivity. Furthermore, DDDM facilitates real-time responsiveness. By leveraging contemporary technological platforms, businesses can generate insights and predictions immediately, enabling rapid optimization of performance and the timely testing of new strategies. Strategic benefits of data-led governance. The application of DDEM yields numerous tangible benefits across the enterprise. Proactive business practices. Predictive analytics allows management to anticipate future challenges or market trends, enabling preemptive actions. Financial institutions, for example, leverage advanced machine learning algorithms to detect and prevent fraud, enhancing customer trust. Similarly, utility companies use data analytics to accurately predict energy consumption patterns, mirroring the capacity for real-time forecasting in manufacturing and supply chain management. Growth opportunities. By analyzing market dynamics and customer preferences, organizations, particularly e-commerce retailers, can identify untapped customer segments and develop innovative products or services, leading to market expansion. Customer engagement and satisfaction. Organizations extensively analyze customer data to build highly targeted marketing campaigns and enhance product recommendation engines. A global online retailer, for example, utilize customer data to personalize recommendations and implement dynamic pricing strategies that adjusted prices in real time, based on market trends and customer demand. This personalization also drives customer retention, as seen with popular online streaming services that use viewing history and ratings to continually engage users and minimize subscription cancellation risk. The contrast between informed decisions, which facilitate sustainable growth, and relying on unchecked gut feelings, which risks the opposite outcome, underscores that intuition carries a quantifiable, high-stakes risk premium. The investment in robust data analytics, therefore, functions as an essential risk mitigation strategy against internal cognitive failures. Best practices for cultivating a data-driven culture. The successful institutionalization of DDDM depends on following a structured implementation process. 1. Define objectives. The initial and most critical step is clearly articulating the organization's overarching goals. Without a well-defined strategy, analytics efforts risk misalignment with business goals, resulting in wasted resources and the generation of insights that lack strategic value. 2. Data preparation and collection. This stage requires determining precise data needs, evaluating and preparing data sources, and systematically gathering and validating the required information. 3. Organize and explore. Once gathered, data must be structured to facilitate the exploration of new patterns, trends, and valuable insights. 4. Implement and evaluate. This final step is crucial for validating insights and measuring outcomes. Action plans must be developed based on data recommendations, resources allocated, and the initiative's progress continuously monitored against predefined key performance indicators or KPIs. This process constitutes a formal feedback loop, a continuous cycle of monitoring, iterative improvement, and adjustment based on empirical evidence. This institutionalized cycle of optimization ensures organizational agility, enabling businesses to swiftly adapt to the rapidly changing business landscape.
The fourth topic is strategic impact analysis, enhancing core management functions, which includes a discussion of the subtopics elevating strategic planning and market agility, precision and resource allocation and operational efficiency, proactive risk management and compliance, and customer centricity and market personalization. Data analytics has moved from a specialized function to a critical strategic engine, directly enhancing core managerial responsibilities across the enterprise. Elevating strategic planning and market agility. Leveraging data analytics is indispensable for modern strategic planning. Data analytics transforms raw data into actionable intelligence used to inform strategy and enhance decision-making. By analyzing past performance and accurately predicting trends, companies make more informed, fact-based choices, minimizing risks associated with speculation. Crucially, integrating data analytics enhances market agility. Organizations that prioritize data-driven decisions respond more swiftly to market shifts and evolving customer needs, securing a crucial competitive advantage. For example, a global coffee brand optimized its site selection strategy by utilizing geographic information system or GIS technology to rigorously analyze local demographics and traffic patterns, leading to improved performance and higher sales for new store locations. This commitment to data-informed strategy allows businesses to anticipate where it needs to go, ensuring sustainable growth. Precision and resource allocation and operational efficiency. Data analytics directly influences resource allocation by providing clarity on the effectiveness of various initiatives. By understanding empirically which strategies yield the best outcomes, management can allocate financial and human resources more efficiently, focusing efforts on the most impactful areas. Operational efficiency is enhanced through the analysis of performance data, which helps identify process bottlenecks, optimize workflows, and improve supply chain management. By addressing these specific issues, organizations can substantially enhance productivity and reduce operational costs. A primary area of impact is strategic inventory management, analyzing historical sales data, forecasting demand, and incorporating external factors such as weather patterns allows for dynamic adjustment of inventory levels. This optimization reduces waste and ensures products are available precisely when needed. A multinational retailer, for example, analyzed historical data and discovered significant sales spikes for certain emergency products before hurricanes, allowing them to proactively stock these items in anticipation of storms. Proactive risk management and compliance. Data analytics plays a vital role in enhancing organizational stability through proactive risk management. By analyzing historical data to identify patterns, organizations can better anticipate and mitigate various risks, including financial risks, operational risks, and market risks. The ability to identify potential issues before they escalate into significant problems allows for preemptive protective measures. This proactive capability is particularly critical in financial contexts, where predictive machine learning algorithms are utilized by institutions to detect and prevent fraud, safeguarding customers and strengthening institutional trust. Furthermore, data analytics supports critical compliance efforts by monitoring regulatory changes and analyzing internal compliance data, helping businesses meet all necessary requirements and avoid costly penalties. Customer centricity and market personalization. Data analytics drives market competitiveness by placing the customer at the center of strategy. Extensive analysis of customer data allows for the creation of personalized shopping experiences and highly targeted marketing campaigns. This capability extends to sophisticated processes, such as dynamic pricing, which adjusts prices in real time based on competitor prices, market trends, and specific customer demand. This dual capability driving internal efficiency, cost savings, while simultaneously expanding market reach, revenue generation through personalization, positions data analytics as a holistic competitive advantage.
The fifth and last topic is implementation challenges and data governance. which includes a discussion of the subtopics, organizational barriers to adoption, technological hurdles, and the mandate of data quality, integrity, utility, and objectivity. While the benefits of DDDM are profound, organizations frequently encounter significant technological and organizational barriers during implementation that must be strategically addressed. Organizational barriers to adoption. The most prevalent organizational hurdle is the lack of clear objectives and strategy. Without a precisely defined plan, businesses risk failing to align analytical investments with overall corporate goals, leading to misallocated resources and the production of insights that hold no strategic value. This failure is often managerial rather than technical. Furthermore, resistance to change can create organizational inertia. Employees may be hesitant to adopt new data analytics services or fear that the introduction of automated, data-driven processes will fundamentally alter or even replace their established roles. Successfully integrating data analytics requires robust change management strategies to mitigate these fears and encourage the adoption of new, data-centric workflows. Technological hurdles. Technological challenges center primarily on data infrastructure and quality. Poor data quality and integration are recognized as the most common technical challenges. Data that is inconsistent, incomplete, or inaccurate drastically reduces the reliability of analytical models and invariably leads to flawed or incorrect insights. This issue is often compounded by data being fragmented and spread across disparate sources and legacy systems, making integration into a single, cohesive dataset difficult. The sheer complexity of managing large data volumes poses another significant challenge. As datasets grow, storing and processing this information demands considerable computational resources. Traditional, often outdated systems may struggle to handle the volume and complexity of big data, resulting in slow analysis times and delays that impede timely decision-making. This highlights the need for substantial investment in modern technology and infrastructure, including cloud-based warehousing solutions and big data processing frameworks such as ETL tools that offer the scalability and flexibility required for advanced analytics. The mandate of data quality, integrity, utility, and objectivity. To systematically address quality challenges, organizations must mandate the adoption of formal data quality frameworks. For instance, the Framework for Data Quality established by the Federal Committee on Statistical Methodology, or FCSM, provides a common, systematic language for managing data throughout its life cycle, moving beyond the traditional focus on mere bias and accuracy. This framework organizes quality assessment into three essential domains, namely 1. Utility. This domain ensures that the data is relevant, timely, and accessible to users. For example, a Department of Transportation case study demonstrated improved timeliness in making roadside inspection data available for review, increasing the utility of the data for safety oversight. 2. Objectivity. This assesses the accuracy, reliability, and coherence of the data to mitigate the threat of bias. A Bureau of Labor Statistics case study examined how the agency mitigated threats to the accuracy and reliability of crowdsourced gasoline price data, which, despite offering efficiencies, introduced potential collection errors. 3. Integrity. This addresses security and confidentiality concerns, which are particularly critical when dealing with sensitive, linked data. A case study from the National Center for Health Statistics described systematic procedures used to balance disclosure risk and privacy concerns with the need for accessible data. The single greatest threat to DDDM's promised objectivity is poor data quality. If the foundational data is inaccurate or contains systemic biases, the analytical models will not only fail to remove bias, but will automate and scale the flaws within the decision-making structure. Therefore, investment in systematic data governance tools and frameworks is as important as investing in machine learning platforms, as strong governance is the prerequisite for reliable, high-impact decisions. In summary, the recent trends confirms that data analytics and data-driven decision-making are no longer optional enhancements, but foundational strategic capabilities required for sustained performance, competitive advantage, and agility in the modern economy. For executive leadership, the path forward must focus on institutionalizing the DDDM process and developing a hybrid workforce capable of leveraging these advanced tools. Required managerial competencies for the analytical era. The modern managerial role demands an expanded skill set that bridges human leadership with digital fluency. Core hard skills must now include digital and social media fluency and, critically, AI competency. Managers must understand the technical capabilities, data requirements, and ethical limitations of machine learning and AI platforms. These technical skills must be paired with elevated soft skills to navigate organizational change. Essential competencies include high emotional intelligence, or EQ, productive communication, and robust skills in flexibility, resilience, and change management. These human-centric skills are necessary to manage the organizational resistance and inertia that frequently derail successful DA implementation. Roadmap for enterprise-wide data analytics integration. To effectively integrate data analytics enterprise-wide, executive management must adhere to the following strategic roadmap. 1. Prioritize objectives over volume. Management must begin by defining clear, high-impact business objectives before indiscriminately accumulating data. Analytical investments should be strictly aligned with these defined key performance indicators to ensure a measurable return on investment. 2. Mandate data governance. Investment in data governance must be prioritized equally with investment in analytical platforms. Leadership must mandate the adoption of formal data quality frameworks that champion utility, objectivity, integrity to systematically assess and mitigate threats to data reliability. Without strong governance, the risk of high-impact, unreliable decisions based on automated bias will skyrocket. 3. Build the hybrid workforce. Allocate resources equally to technological infrastructure such as modern data warehousing and ML platforms and targeted managerial training that fosters AI competency and effective change management. 4. Institutionalize iteration. Embed the implement and evaluate phase. Continuous monitoring against KPIs as a non-negotiable part of strategic governance. This commitment to continuous monitoring and iterative refinement ensures that decision-making remains adaptive and evidence-based, maximizing long-term profitability and competitive agility. By formalizing the DDDM cycle and cultivating a culture that views data analysis as both a powerful revenue driver and an essential risk mitigation strategy, organizations can successfully harness the strategic imperative of the data economy. There it is, strategic imperatives in the data economy with the theme, an executive overview of data analytics and its transformative impact on management decision-making. The references used in the production of this lecture video is shown on the following slides. Thanks for watching and stay safe always.